Okay, so we're going to quadratic equations overview, and I've written out three forms. Even with linear equations, there are forms, but you tend to use something called the slope y-intercept. So when we're just working with linear stuff, that's fine. We had like y equals mx plus b. This is almost the most common form you'll work with linear equations because it's easy to see a y-intercept and it's easy to see a slope. But when it comes to quadratics, and the reason to use this one also for linear is because it's just so helpful and it's so useful. Quadratics, though, there are three major forms that you tend to use in math. I mean, you can technically make more, but the three forms are called standard, which is just an easy way to look at everything. It's very simplified looking. Vertex, which is great for graphing, and especially looking at the vertex of the equation. And factor form, which is also great for graphing, but also tells you the x-intercepts of an equation by just looking at it in its algebraic form. So these three are extremely popular, and what we have to realize is they all represent the same equation. Okay, so what I'm going to do is I'm going to build a quadratic, and we're going to talk about how you can go like back and forth between these forms and how they're actually the exact same thing. I'm going to bring up Desmos really quickly here and show you that I have the three forms here. Now I'm going to turn off the other two for a second. We don't need green and we don't need black at the moment. So here's our red form. And in this one, you've noticed I have a is equal to 1. So this is y equals 1x squared plus b is also 1. And, oh, that should not be times c. That should be plus c. Great. And c is 1. So here's our quadratic of it. Now, if we take a look, and I'll write this one out. Essentially, think of this as 1x squared plus 1x plus 1. It's not great for looking at the graph. Like, I mean, my vertex, is that my vertex? Is not a super easy number. I don't recognize 0.5 or 0.75 in any of the values I've used there. But it's a very clean form we tend to use for quadratics. If I go to the vertex form here, notice that a is still 1, and there is one commonality. If you notice in the standard form and in the factor form, a is the exact same all the way through. That's going to be important when we switch back and forth as a way to kind of check our work. But more importantly, and I know this isn't the cleanest way to look at it, that h there, that means 1, so think of x minus 1, and that k there is also 1. What's nice about that is if you look at our vertex, it's 1, 1. So the h and the k actually tell you what the vertex of the quadratic is. So that's really helpful for whenever you're asking for a minimum or a maximum of something, okay? And then let's go to our factor form. Again, a is still 1. We use the a all the way through. If you notice here, r and s are both the same value. They're 1. I'm actually going to change them. I want them to be two different values because I want to show you. There we go. That's great. What's great about factored form is they tell you the x-intercepts very nicely. So notice r is 1. 1 is one of the x-intercepts. And s is negative 2. One of the x-intercepts is negative 2. So they very quickly tell you what the x-intercepts are. So these are all major points on a quadratic. The one thing that standard does tell you really, really quickly, I'll turn these off, is the standard form will tell you the y-intercept. See how it's 1? C. Whatever c is the y-intercept. Okay, so that's how they relate to graphs very simply. But we're going to go about changing all these numbers, and we're going to manipulate an equation here. So I'll just do a really quick note on the side here. Note that c will give you, we'll write it in here, y-intercept, okay? Intercept, I almost forgot to spell it for a sec. The h will give you the x value of the vertex, and the k will give you, I'll just go through that. K will give you the y value of the vertex. I'm just going to write it like that. Does that make sense? Okay. In other words, sometimes I even write it like this. X with a little subscript v, all that means is the x value of the vertex and the y value of the vertex. If I ever write it like that, that's all I'm referring to. Okay. And then the r and the s will both give you x values of the x-intercepts, they're called x-intercepts. In other words, think of it like this. You'll have 0, because if it's an x-intercept, y is always 0. It'll be 2 coordinates. The y value is, oh, sorry, that's not the y value, that's the x value. Y's are always on the second one written. This will always be 0, okay? And this will be r or s, or sometimes they'll write like this, x1, comma 0, and x2, because there's usually 2 x-intercepts. Not always. In fact, you can have none. But these are just like quick notes on what's good about these forms and why we use these different forms. So, more importantly now, let's actually get an equation and see it in action, how it's very helpful to us. So, if I give us y equals, let's say, 2x minus 1. I want to make sure these are x plus 1. There we go. The very first thing I want us to do is try to figure out which of the forms this is.
Factored.
Perfect. It's factored. That's excellent. So right away we know this is factored. So what's great about this is we can start to use parts of this information to graph. So if I wanted to do a rough sketch of this graph, I'm going to do it in green down here. I know that one of my x-intercepts, and this is the tricky part about factored, it's actually the opposite of what the number is in the brackets. I'll show you very quickly here. If you notice, I'm going to turn this one back on, the green one. If you notice, the value is 1 for r. But if you notice there's a subtraction sign in front of it, it actually says x minus 1. But the x-intercept is positive 1. Same with the other one. For s, it's actually x minus negative 2. 2 negatives together make a positive. Even though it looks like positive there, the x-intercept we're talking about is a negative 2. So let's go back to our equation and try to make sense of what I just showed you there. It's not great because I use 2 values that are the same. I use those 2 values because I wanted to make it a relatively easy one. When we're converting, I'm going to use a different value to start just to emphasize this point, and then we'll go back to the 1, okay? Let's just say that this is, I don't know, 3, okay? If I'm going to write that, I actually have to go, okay, I need the opposite of 3, so one of my x-intercepts is actually negative 3 and 0. So that's like over here, let's say. I'll say that was negative 1, negative 2, here's about negative 3, okay? This one is the opposite of negative 1, so it's positive 1 and 0. So that's probably about there. That's probably about positive 1. The a value is positive. The a value is really important, whether it's positive or negative, because it tells us whether the quadratic goes up or down. If it's positive, it goes up. If it's negative, it's a quadratic goes down. Because now that I have these 2 points, I can go like this, or I can go like this to connect them. I'm not quite entirely sure. Because we know that's positive, it opens upwards, okay? So this would be considered a rough sketch of this one here. Now that 2 is important. It tells us about stretching and compressing, but we're not going to get too much into that until we go into maybe like the vertex form. Okay, does that make sense as a rough sketch of it? So I'm going to take that value now, and I'm going to do some converting. So I'm going to change this equation just a little, and I'm going to go back, okay, to 1. So I'm going to say y is equal to 2, x minus 1, and x plus 1. Okay, I need to go from factored form to another form. Let's say any form. The simplest one to go to is actually to the standard form, and you do something called expanding. Okay, so we have to do expanding. Expanding is, have you ever heard of FOIL or like a rainbow method where you're multiplying all the values? So you multiply everything across here. So in order to get the factored form, what I'm going to do is I got to take this first one, and I multiply it by this, and I take the first one, and I also multiply it by that value. Then I take the second value here, multiply it by the first, and I take the second value here and multiply by the second. To multiply all of these. Have you ever seen this done before for expansion? Yeah, so this is something we're going to do very quickly. Y equals, I still have the number 2 in brackets. X times x is x squared. Okay, that's the black ones. For red, x times positive 1 is 1x, or I'm just going to write it as x, okay? Blue, negative 1 times x is negative x. And negative 1 times positive 1 is negative 1. I kept all the colors the same there so we can simplify. What's neat about this one is the x values are going to cancel each other out. We have a positive and a negative, so they're going to create a 0, just like in the game, that little green one. They're gone. And we left with y is equal to 2x squared minus 2. But I still have to distribute. Shrink this a little more. And this 2 has to be distributed to everything. So the standard form becomes 2.
Why is it negative 2?
Because, oh, you're right. I was jumping ahead. That's negative 1. Thank you. Let's just erase. Why doesn't that erases that? Doesn't erase that. Okay, good to know. I'm going to scratch it out. I don't know. Hey, there's a 1. Great. Very nice 1. Do you know why I wrote negative 2? I was already looking ahead of distributing the 2. So 2 times negative 1 is negative 2. That's why I was kind of jumping ahead of myself. This standard form is kind of special. If you notice, it's kind of missing this. It's not that it's missing. There is a value for b. It's technically the same as writing 2x squared plus 0x minus 2. That looks a lot more like this standard form. The thing is, 0 times x is 0, and 0 plus anything doesn't change it, so we don't write it in, okay? So it is standard form, it's just kind of missing one of the terms. There's usually 3 terms in standard form. What's nice about this is it tells us our y-intercept, like we talked about before, right? Here's the c value, right? There's no x beside it, so that must be the c value. The y-intercept must be negative 2. So if we were to draw this out, we know we have a negative 2 y-intercept, whatever it is. Remember, this one was a little different. We have a positive and negative 1, so it has x-intercepts there. That makes a lot of sense. We can't go down and connect all those dots. We can go up and connect them because the a was still positive. Okay, so that's making a little more sense. And we've converted to standard. So we've gone from factored to standard. Now, a hard process is to actually get into vertex form. So there's a couple ways we can do it. We can go from factored to vertex, but the common way to do it is completing the square. Have you ever heard about this term? We'll move to a new page when we do it here. So 2x squared plus 0x minus 2. So I'll rewrite this. Y equals 2x squared. Technically this is 0, and we said minus 2. Here's our standard, okay? Our standard form of a quadratic. I need to change it into a vertex form. So there's a process, and then there's little equations we can use. Whichever is simpler to you, we can focus on that. What we're going to do here is we're going to go in the process here. The very first step to this, completing the square process, is we're going to start to think of this equation as just the first 2 terms, okay? And we need to make sure, actually in this case this one's 0, so it might be easier if we use the formulas. Okay, before I do this, you know what we're going to do? I'm going to jump into Desmos and quickly just show you how those 2 equations ended up being the same. Okay, so we'll turn these off. We had originally one equation that said y equals, our a value was 2, and then we had x minus 1, and we had x plus 1. What happened there? I forgot my x plus 1 in brackets. So those are 2 x-intercepts. We know that. We converted to standard form. Y equals, and we got 2x squared, and then just minus 2. Actually, I'm going to write it in as plus 0x minus 2, just so you can see. If you notice the blue, when I turn it off, it just overlaps the red. They are identical. So that's what we mean when we're converting to different forms. Same equation, same graph, just a different form. This told us that the y-intercept was negative 2. Yep, that's great. So we've gotten quite a bit of information out of this. The last thing we have to do is figure out the vertex. Now, in this form, the vertex happens to be right down the line, but there's many other quadratics like that one there where the vertex isn't on the line, so it's a little harder to see. So let's go. I'm going to pause this for a sec. Okay, so I've pulled up the 2 equations. I didn't even have them memorized, so I have to go find them again. The h value, or the x value of the vertex, is equal to this equation. and the k value or the y value of the vertex is equal to this equation. So these equations here, bunch of letters, a b, an a, a c, a b, an a, you know, how's that helpful? Well, let's remember our vertex form. Y is equal to a x minus h squared plus k. Write that in blue, we'll write k just in green here. So what it's saying is this equation, when you take your standard form, which I'm going to write out again, y, we did it in red before, y is equal to a x squared plus bx plus c. This equation, what it's doing is taking the values of standard form, allowing you to plug them in, and giving you the h and the k instead of going through that really long completing the square process. So, negative b, that's referring to this b value, okay? A is referring to this a value. C is referring to whatever value C is, and then the b and the a we've already talked about those values there. Whatever your answer will be the number that you plug in for k, and whatever the answer will be here will be whatever you plug in for h, and it will give you your vertex form. Okay, so we're going to go through that. So very quickly, like we talked about before, a is the first value there. It's actually going to be the exact same value here. Really, really helpful. We know our a already. It's whatever the a is there. Our b value is 0 in this case, and our c value, I know my colors aren't really matching right now, is going to be negative 2. So when we go to plug them into these equations, they're going to give us our h and our k. So I'll say, I'm going to call it the x value of the vertex instead of h, okay, because that is kind of what we're finding, is equal to negative, well, what's our b? Our b value is 0, so negative 0 divided by, still the number 2, whatever a is. Well, I guess I can highlight them, that might help a little. Here's our b, here's our b, it's the same. Here's our b, here's our a value, and whatever I write in here is going to be the a. Well, it happens to be the number 2 also, so it's 2. 2 times 2. Okay, so let's equate this. Well, negative 0 is 0, and 2 times 2 is 4. And 0 divided by 4 is just 0. So it turns out the x value of our vertex, or the h, is the number 0. So it's going to be equal to 0 in this case, okay? We're going to do the same equation over here. The y value of the vertex is equal to c, I'll highlight in yellow, c, which happens to be negative 2, and again, that's the value we're going to plug in there. So we're going to put in, I do that every time, negative 2, I'll highlight it in yellow so that we know that that represents our c. Ooh, that made it hard to see. Let's move some of this. I know we can't quite do this on paper. I do want to fit it in there. I don't remember how to do it, but there's a way to cut and move. I'm not going to do it. I'll just keep writing, sorry. C minus b, we talked about before, is 0, so b squared, so 0 squared, divided by 4 times whatever a was, and a is the number 2. Does those numbers make sense? I'll quickly highlight them. I squeezed them in a little. That was our b value. Remember, we had it highlighted. B is in green, and a is in blue. There's our a value, okay? So we equate them. Negative 2 we leave. 0 squared is 0. So we're subtracting 0 divided by 4 times 2 is 8. 0 divided by 8, still 0. We get negative 2 minus 0, negative 2. So it turns out our k value is negative 2. So instead of going through that process, I know this is very messy. I should have wrote it much cleaner for you.
You can understand it.
Yeah, you can understand it? Good. Our h, this value here, we're going to replace with the number 0. And our k, that number there, is going to be replaced with negative 2. So our vertex form, we'll rewrite it. Y is equal to, remember it's still the number 2. It never changes no matter what we do there. X minus 0 squared plus, and because it's negative 2, I don't need to write plus negative 2. I can just write it as subtract 2. So subtract 2. So here's our vertex form. Let's put it in Desmos and see if it overlaps with everything else we had done. Okay, so in Desmos, what that should be is y is equal to the number 2 bracket x minus 0 squared minus 2. And it turns out the green overlaps the red, which overlaps the blue. So, can we see the blue? Yeah, we can. They all overlap each other. So these three equations, 1, 2, 3, are all the exact same formula, or sorry, they all have the exact same equation, but they're written in different forms of the equation. And going between them is something that we do with quadratics. We go from like standard to factor to vertex because each of them give you a different piece of information. Like this vertex form told us the x value of the vertex is 0 and the y value is negative 2. Yeah, it's 0, negative 2. That just so happens to also be the Y-Intercept, which the standard form told us, the blue equation, and the red equation tells us the 2x intercepts. So these three forms tell us at max 4 really important points. The vertex, if there's any x-intercepts, what they are, and the y-intercept. So that's why we have three different forms, because each of them gives us a different piece of information about the graphing of a quadratic. Okay, that is